Okay, so we're going old school arcade with this one. We're going to make a game like Missile Command. So we'll call it Comet Control. So basically, it's going to be a slight update of the visuals rather than just having lines coming down. We're going to have particle systems, and those particle systems are what you're going to be targeting. Now, I've done absolutely nothing other than dragged and dropped the images from an external folder into the scene, and we're going to start from scratch. So first, let's take this image mound. We're going to drag and drop this into the scene. Now, depending what you're doing, you may not actually want the mounds to be that high. So I want to show you a few things. One, you can really reduce the severity of the curve without actually having to redraw this. So if you come over here to scale, okay, for the Y scale, drop it down to like 0.4. See, that flattened it out, and it didn't like really, yes, it did distort it, but not in a way that's not aesthetic. Part of it is because it's a flat shaded image, but it's not like the edge is all broken up. So in other words, you can definitely modify the images you use if they're not quite what you want them to be. Now, one of the ways that you can tile an image so you don't have to draw it over and over again is you line the edges up. Well, this edge is bigger than this edge, okay? So what you're going to do is you're going to want to flip it. So let's copy and paste it. We'll slide it over, and you can see the edges don't match. So one of the options that they added in Unity 5, I'm not sure if it was there from the beginning or if they did it in 5.3, you've got this flip section. Just choose flip X, and now this edge is this edge. You've created a mirror image. So if there was like a mirror between them, you've created, that's what it would look like. So you've created like a mirror image. Now the edges match seamlessly. What you can do is you now take both of these, copy and paste, slide over again, and now those edges match. Grab everything, slide it over, push down, and it looks like we need one more. So we'll just grab this one, copy, paste, slide it over. There we go. So we started with something that was really too severe, and we're able to smooth it out. So now what we're going to do is we need to place our missile centers, and we need to place our cities. So that's pretty straightforward. Just drag and drop. And we'll put the cities in the little troughs. And you can either drag and drop or just copy and paste. Either way, it's the same thing. There really isn't much to the city right now. Ultimately, we are going to put some controls on it, so technically you could just make one and then copy it, but it's pretty easy to retrofit these, so to speak. What change I make to one, it's easy enough to make to the others. So we'll just get rid of the numbering at the end. Now, if you're making a much larger scale game with many scenes, then yeah, you really do want to, sorry, didn't mean to zoom in like that. You really do want to put on all the bells and whistles onto the object before you copy and paste it. But since this is a fairly simple game, I'm just trying to demonstrate how it, falls together pretty quickly. So now you already have the basics of the environment. Now, let's take our missile base, put it here, and we'll take our other missile base, so we'll copy and paste, put it over here, and now we'll just run to see how it looks. Basic, but that's what the original game was like, though. Pretty straightforward. So we can do other minor things, like we can add maybe a background, like a solid black background. It had like little twinkling stars, that kind of thing. But right now we're just looking at the basic layout and then the functionality. Now, to create the comets that are going to descend from the top. A little bit more challenging. I'm going to go through it pretty quickly because honestly, to explain the creation of the particle system, particularly for this one, would probably take a good 20 minutes. So game object particle system, and we'll just call it comet. And we want to do a bunch of things. So we're going to change the shape to a circle. We are going to rotate it, the x to 0, so it's 0, 0, 0. That way it's facing the screen. We need to shrink this diameter, so if you go to shape, it's actually called radius. So you shrink that as much as possible. Start lifetime, we'll put that at about 2. Start speed, going to put that at about 0.2. So that way we want it to look more like a glow as opposed to these individual particles. You want it to be more of a glow. Color over lifetime. I'm going to add a control there. That way it doesn't change transparency for most of the life. And then at the end here, we click. We drop it all the way down to, like, the 60s or the 50s. Now, size of a lifetime. These two often go hand in hand when you make something transparent and smaller, particularly if it's like smoke, fog, maybe even an energy effect. The only time that you wouldn't decrease smoke and size is if it's meant to be, color and size. The only time you wouldn't change color and size is if, say, it's something solid like bits of rock breaking off. You probably wouldn't want to make those transparent, or pieces of wood splintering. You might change the size, but not so much the transparency. What I'm going to do is actually going to add 2 keyframes, one near the beginning, so that way this doesn't start off full size, and another one near the end so it tapers off. So basically, it eases into the scene rather than just only appearing solid. It eases in, and we could actually go back to color and do the same thing. So let's add one more position here, and then we'll go here and make this kind of transparent. Now, it probably doesn't look like much of anything because it's not moving. Let's bump up the emission. I believe I had it up to 90 when I was testing this. And simulation space means world. So when this moves, what's going to happen is it's going to leave particles behind. If you leave it as local, it won't leave particles behind. The whole thing will move solid. And I believe that's about it. Just to test it, let's add physics 2D. Well, we're going to need a rigid body anyways, but we'll probably get rid of the gravity when we're actually running the game. So we'll put on a linear drag of 4. So linear drag of, rigid body allows for the application of gravity and velocity as well. Let's go ahead and pre-warm, and let's move it to the top. See, now that I'm moving it, you get a better sense of what it's going to look like. Now let's run it. So kind of like a comet, a little bit bigger than I'd want it to be. Start lifetime is probably a little bit too long. Maybe drop the start speed a little bit. And you can see that quickly this becomes, don't want to say a quagmire, but very quickly you can really get caught up in doing this one thing. Okay. Now true, when it's a game, and this is what you're seeing over and over again, yes, it's important to take that much time, but from a tutorial point of view, it really becomes quite time consuming. Alright, so let's take that comet, drag and drop it into our asset area so it is now a prefab. And let's delete the original. So now we've got all the basics. We've got our ground, we've got our cities, and we have our missile launchers. So now we also need to create our missiles. So we'll take the missile image, drag and drop it into the scene, and then drag and drop it back out just to create a prefab. We're not actually going to do much with it at the moment. So now rather than just being an image, it's actually a prefab with a transform and a sprite. Let's go ahead and add a rigid body to that as well, but in that one we definitely don't want gravity. Okay, so it took a quick break there. If you notice, 2 new images appeared, and this is going to be another enemy that's going to show up during the game, and this is going to be our custom mouse, because in a game like this you'd expect it to be like a crosshair or something, not just the default mouse. So let's get to work on those things. So game object, create empty, and let's call this GM, short for our game master. And just to be clear, calling it game master in and of itself means nothing. It's just so you, the programmer, knows what you're using that object for. So let's go ahead and create C# script. We'll also call it GM. We'll click on the object, drag and drop the script, and now we will open that script, and we're going to do a few things. I have some of this stuff written down in text files, so don't worry, anything you see will be explained. Let's zoom in a little bit. So first thing, we need to say what image the cursor is going to use. So first we have to define the variable, and this is a 2D texture variable. So public texture 2D default texture, will save that. And you'll see it appear over here. Just drag and drop the crosshair image onto it. Now we just need one additional line to actually set that. Well, actually we got 2 more variables, but it's pretty much just copy and paste with these. You're not really going to do anything with them. So when you're setting the cursor, you need 3 settings, 3 arguments. There's the image, there's the cursor mode, and then there's the location. So public cursor mode, and the variable name I'm using is curmode equals cursor mode dot auto. And public vector2 hotspot equals vector2.0. Don't worry too much about exactly what these do, just know that you need all 3 for this demonstration, and really this is the only one that you care that much about. These 2 are just telling the mouse to work as normal. We don't want to deviate from the normal mode or from the vectors. And now we go ahead and set the cursor. So we'll do that in start. So cursor dot set cursor, parenthesis default texture, that's this, hotspot, that's this, and cur mode, that's this. So you've defined the 3 variables and you drop them into cursor dot set cursor. We'll save that, and it should be all it takes for a custom cursor. Yep, there we go. You now have your custom cursor. Now, what we need to do in addition to that is we need to track the cursor position. And the reason for that is because when you fire off the missile, it has to shoot to where your cursor is. So we need to capture, we need to store that position of the mouse. The cursor mouse, sorry, I use the words interchangeably. So what we're going to do is in the update section, just modifying this from another script. So we need to define those 2 variables. So public vector2 and then the name is mouse position. Public vector2 Now normally I use obj at the end of a variable to let you know it's an object, so don't worry too much about the fact that I normally do that. It doesn't actually define it as a transform or game object variable. I just use that to indicate it to myself, but you don't actually have to do that. Okay, so what this is doing is this is taking the variable mouse position. What it's saying is, let's look at the x position and the y position of the mouse. So input.mousePosition.x, input.mousePosition.y, and drop it into this vector2 variable. So since these are two vectors, x and y, we have to drop it into a variable that can store two vectors. So vector2 mouse position. So what's the x and y positions of the mouse? Drop it into that. But now we need to translate that into the units that Unity uses. So we take that variable that we just defined right there, and we filter it through camera.main.screen-to-world-point and drop that into object position. So you're taking the mouse vectors, dropping it into here, taking that variable, filtering it through this, and dropping into here. So this is what we really want. And now what we're going to do with that is going to tell us where we need to shoot the missile at. So what we're going to do is really the fire button is all we need. We don't need any other actions. So let's go ahead and create public key code. Fire missile. And we'll save it. So it's attached to that, and there's the fire missile, and we'll just use space. Alright, so we created the key code to capture if this is being hit. Now we need to actually check for it. So, in the update section, we're going to have an if statement that checks for the input. However, before we check, we're going to want to make the GM object aware of the missiles so it can actually instantiate them. So public transform missile obj, and that's what I was saying about how I use obj at the end of a variable. So GM missile obj, and we just drag and drop the missile onto it. Now there's a few complexities. Since it actually looks like a missile and isn't just like an energy ball shooting out, we're eventually going to have to rotate this, or else what's going to happen is the missile will be pointing upward, but it'll be moving diagonally. So we'll come up with a method to rotate it towards what's being shot. So if input dot get key down, because we don't want it to be rapid fire, we only want it to be true for the single frame that you press the button down, and we said it's fire missile. So if fire missile is pressed, then we need to instantiate the missile object. Where do we want to instantiate it? Well, we're eventually going to shoot from two locations, but we'll keep it simple. For now, we'll just do one. So negative 7.32 and negative 4.11. Well, I'll be able to see it even when I put the script up. So instantiate new vector 2 negative, let's just do negative 7 and negative 4, and it should be close enough. So the first argument is the name is the transform, the variable missile object. The second argument is actually a two-part argument. It's the vector 2 positions, and then the third is the rotation, and that goes back to the missile object dot rotation. So it instantiates it there. So what's going to happen is when we hit the spacebar, it will appear here and then won't do anything. See, there we go. So let's end this video here. Actually making this move, while it's only like 1 or 2 lines that's required, the logic behind it is a little bit more complex. I'd rather deal with that in a video by itself. So we'll do that in the next video.